Okay, thank you for waiting, everyone, and welcome to Edge versus Cloud, where Machine Metrics co-founder and CTO will be discussing the differences between edge and cloud computing and pros, cons, and how they work together. We'll get things started, Jacob. Great. A few notes before we get started. The webinar is being recorded, and we'll send out a link to the recording via email by the end of the week. Additionally, we welcome questions. So if you have anything that comes up, feel free to throw it throughout the presentation in Q&A or chat. And I'll be monitoring those personally, so we'll try to get to as many as we can. Just a quick introduction. My name's Gwen Lamar. I'm a marketing manager here at Machine Metrics. I'm one of the folks that helps produce our webinar series, and I really enjoy it, and truly am excited about this one. Jacob, I guess I'll just let you take it from here.
Excellent. Thanks so much, Gwen.
You're welcome.
So as Gwen said, I'm the co-founder and CTO here at Machine Metrics. We've started this company about 6 years ago now, and we're really excited about the stuff that we're doing, and hopefully today you guys can learn some stuff about Edge versus Cloud, and like Gwen said, we're happy to answer questions all along the way. Before we get started, I just wanted to bring up a few things. Machine Metrics introduced a COVID-19 response program where we're offering free access to the platform for any manufacturers that are building things in relation to the COVID-19 response. Whether you're manufacturing PPE or ventilators, please reach out and maybe there's something we can do to help. So Machine Metrics is manufacturing's first industrial IoT platform for machines. And we have customers all around the globe representing thousands of machines and hundreds of customers connected. So let me introduce you to that first industrial IoT platform for machines. We turn machine data into actionable insights that automate processes around the machine. First, our edge can be used to connect to any machine. Most of our customers connect them themselves without any prior knowledge of machine metrics. Data can be collected from PLCs or sensors on the machine or both. 70% of our customers installed machine metrics without any help from us. We transform this data into standard data structures so that that data can be understood. For machines, that structure is commonly MT Connect, but we translate all different machine types into a common protocol so that you can reason about it in a consistent way across many different types of equipment. Next, that data is streamed into our cloud, where the data structures are specifically designed for machines and the high volume of diagnostic and sensor data that's associated with them. We aggregate that performance and the machine condition data so that it can be visualized through some out-of-the-box reporting and applications, or you can connect it with your own BI tools. Now, patterns in this data generate insights that initiate actions through configurable workflows. These triggers can send notifications or create entirely new business processes, including those built into Machine Metrics that are designed to optimize the operation of the machine. The insights and actions generated from the data are what drive true value on the factory floor. For example, production history and machine conditions can be used to notify and prescribe to operators the steps they need to perform more optimally certain tasks related to the operation of the machine. We also enable service providers to offer improved service with remote access to diagnostic data and the ability to send instructions to the operator when a machine enters a state, such as an alarm. This communication enables an operator to efficiently handle more machines. All right, so the topics that we're going to discuss today are history of computing. We'll go over that very briefly, specifically related to how we got to cloud and edge. And let me actually turn my video on here. I think my video's on. We're going to talk about the advantages and the shortfalls of the cloud, what edge computing enables, and how the cloud helps the edge overcome some of its disadvantages. And then we'll cover some edge computing use cases as well. So first, we're looking at how did we get here? There's the mainframe. This is back in the 60s and 70s, where centralized computing systems were there so you could schedule time to run calculations from dumb terminals. After that, we went to a client-server model, where you have slightly dumber centralized systems, mainly for storage, but with more intelligent clients doing the work in a distributed fashion. Think of, as an example at least, a file store where you're actually loading up something in Lotus Notes or Microsoft Office to do actual work and then storing the content back on the server. Then we moved to the cloud, where more of that centralized computing was done on servers, and the clients were mostly just there for display. Think of like a web browser pulling up Google Docs. Now what we're getting into is Edge. And Edge allows us to distribute complex tasks to clients and little PCs that run right at the edge, hence its name, while still allowing for general latency forgiving tasks in the cloud. So we can combine benefits of the edge with low latency access to make actions and still have the power and scalability of the cloud. So let's first talk about cloud computing. So some of the advantages of cloud computing are the scalability. Now, think about Amazon Web Services or Azure or Google Cloud. They have servers spread across the entire globe, and they're organized. They're organized into regions. Amazon Web Services, for example, if we dive into, say, the Oregon region, that's comprised of a number of different things called availability zones. Each one of those availability zones is further broken down into data centers. Each one of those data centers is separated by many miles. Each one of the availability zones has dedicated power, networking, resources. So if anything goes down, there's another one to pick it back right back up. And that allows machine metrics to add more and more, and companies like ours to add more and more machines without needing to do any additional work. It also allows for us to mitigate any sort of disasters, either actual natural disasters or just technical issues, network outages and so on, by allowing us to spread our workloads and replicate our data across multiple regions, multiple availability zones. We're able to recover in the event of a failure in seconds without anybody actually noticing. Take that a step further, and you can then replicate the data from one region to another across the entire continent or across the globe, so that if there was some larger issue, you could spin back up and recover with minimal downtime. You can imagine that this infrastructure would take a lot to actually run. And so there's a tremendous amount of cost savings by taking advantage of cloud providers and what they have to offer. Another thing with cloud computing, and SaaS in particular, is that you get automatic updates. Because the interaction with it is managed by a central system, we're able to keep all of our systems and services up to date for you. There's no need to install anything. And then lastly, by being in the cloud, you enable a lot of new possibilities like collaboration or offsite access. You can check to see, for example, how the machines in your shop are doing in real time from the beach, if you want to do that on your vacation. Now, some of the shortcomings come inherent with just being on the internet. Reliable network required. If you don't have an internet connection, you aren't going to be able to communicate with the cloud. And just by the nature of physics and having to send the data from some distance, you're going to have some latency. So there's certain applications that you might not be able to accommodate with a cloud solution, a cloud-only solution. Two other things that are more about trust involve loss of control. If a server goes down, you don't have the ability to walk into your server closet and replace it. And you also have to trust third-party security. You have to understand that companies like Machine Metrics are taking on that role for you. And one thing about trust in the security space is that you should look to the people you trust to see who they trust. And one example of that is the fact that Machine Metrics is an AWS Advanced Tier Industrial Partner. We've been recognized in our ability to provide powerful cloud solutions that are upheld to the highest standards for disaster recovery, resiliency, and security. So edge computing. Some of the new possibilities on the edge here, which allow for the cloud to kind of expand, involve speed and latency as one. So you can make decisions really quickly in milliseconds, not seconds. You don't have to send the data all the way to a cloud system for that data to be processed and analyzed and then action taken. It can all happen right there at the edge. Now, an edge device looks like this in Machine Metrics case. It's just, I have an old one, a black one, one of our older models. It's just a PC, a Linux PC in our case, that runs a bunch of custom software, and it's connected to the equipment and the internet. So what that allows us to do is filter the data. We can filter the data for just what actually matters and analyze it. So if we're connecting to a bunch of sensors that we're sampling data at many hundreds of samples per second, you don't want to send all that to the cloud necessarily, depending on your use case, because you can actually understand the relevant data on the edge and only send what matters when certain thresholds are reached, or averages, median, standard deviations. Next, and that actually results in a significant cost savings. You can imagine sending many hundreds of hertz of data to the cloud in streaming fashion. You're going to have a higher bandwidth cost there. So by reducing that, you can lower your costs as well. Another thing the edge provides is the ability for the cloud to have some network resiliency. The edge doesn't need to be online all the time, and we can get into, with the use cases, how we can take advantage of that. Lastly, security. The edge acts as a bridge between your IoT equipment to enable it and the cloud. By sitting in between, we're able to make sure that we only reach out from your internal network and never reach in. And that's how edge devices should operate. You can imagine in a world where there is no edge device, to have a cloud system talk to a piece of manufacturing equipment, it would need to have some direct connection to it, either through a bunch of routing rules or what, but it would need to be able to talk directly to that equipment. By using an edge device as that kind of bridge, you make the installation a lot simpler and provide a much more secure solution. Now, part of this disadvantage is sort of a double-edged sword, and that comes with incomplete data. When you start making decisions on the edge about what data should and shouldn't be sent to the cloud, you might miss some stuff. But there's not much you can do about that other than trial and error. You have to kind of work at that. Another disadvantage of edge computing is device management. You went from having one central place with all of your devices or your entire cloud system to having a bunch of independent edge devices spread across an entire geography. And you need to keep them up to date. You need to keep them secure. So that causes some issues. Also, if any one of them fails, each device can contain a lot of information about their configuration. So it's difficult to manage that on a case-by-case basis when things fail. Lastly is scalability. You have a dedicated piece of hardware that's used for a specific task, making it harder to do new things when that require more resources. Now, the edge and the cloud actually work really, really well together. The edge can buffer data. So we can have that always on connection with the piece of equipment. And if the internet goes out, we can just hang on to it. Once the internet comes back or that network issue is resolved, we can start streaming that data again. Again, we bridge that data, that connection, so that there's a secure connection to the cloud, making the installation a lot easier for connecting equipment to an IoT system. And the cloud can also provide a way to manage your fleet. Device configurations are backed up off-site for quick replacement in the event of a hardware failure, so that you just swap it and the configuration just comes into the new device and you don't have to do anything else. And we can send just what matters. You don't have to continuously send high frequency data to the cloud. You only have to send what actually matters. And you can also take real-time action. You can analyze the data with sub-millisecond latency and do some pretty powerful things to improve your business process. Are there any questions so far? Gwen? Okay.
None yet.
All right. All right, let's get into some use cases. So one of the use cases is to be able to translate and standardize the information received from these distinct device protocols into a common data model. One of the use cases to this point, manufacturing has a number of different protocols. You have FANUC controls and Mitsubishi controls and Citizen machines and OPC UA, Modbus TCP, Ethernet IP, and they all speak their own protocols. So being able to translate that information in a centralized place right at the edge and send that to the cloud in a consistent manner is a really powerful use case for the edge. And then capturing sensor data at very high frequencies, hundreds, 500 or a kilohertz rates, being able to sample that down and only capture the meaningful insights from that data to send to the cloud is another powerful use case of an edge device. In the alternative, you'd have to send all that data up to the cloud, which would take a significant bandwidth burden and further cloud processing burden. You're able to distribute that weight across your entire edge fleet instead of taking that burden all in the cloud. Now, this part gets a little interesting. So you have an edge device that has a lot of computing power, and you have high frequency data, which is actually really important for starting to predict when a machine might fail. So you can use the edge device as a way to analyze that data at high frequency rates, not just to capture thresholds and basic things like that, but you can also use that data to develop machine learning models that understand when a machine will fail based on a number of different metrics. One example of that at a customer of ours, we were able to stop the machine 45 minutes before a tool fails just by looking at high frequency load data, but being able to capture that information alongside a bunch of other very precise information about the tooling that's being used and how many parts are being produced. So we're able to develop these models in a way where we can have a very high level of accuracy, over 99% confidence in stopping the machine. That enables you not just to not scrap parts, but also run a tool all the way to failure. It's really common for manufacturers to set their tool life counter on their machines far below the full life of the tool. And by trusting a system to tell you when the tool is actually at life, you're able to get a significant amount more parts out of a single tool. And then you can start to expand because you're in the cloud. You can provide different sorts of remote support tools. One example of that would be maybe to have the edge device act as a bridge to service providers, so that machine builders, so that they can diagnose issues and address them remotely. Having the edge talk directly to the machine and provide a secure internet connection back to the machine builder so that they can address the issue without having to come out on site, or at least learn enough about the problems that when they do arrive, they can come with all the parts necessary. And then the last item here is to take action. So as you're capturing all this data at the edge and machine learning models and even just basic thresholding algorithms and other rule-based operations are deciding that something needs to happen, you have a device at the edge that can talk to your manufacturing equipment to take action. Some examples are to stop the machine, as I said, we're doing with one of our customers, but you can also offset change the offsets on the control if tools start to wear a little bit and parts approach being out of spec. Maybe even instruct a robot to go and retrieve new tools exactly when they're needed and bring them to the station so that the operator doesn't have to go find them. And then notify a machine builder of a problematic component. Recognizing that, you'll be able to speed up the repair of a piece of equipment and reduce downtime. Some of the questions that we got here: how long will data be stored if the edge, in the edge if we lose cloud connectivity? So it depends. It depends on how much data you're capturing from the equipment, how many pieces of equipment that edge device is responsible for, what the frequency and rate that you're capturing data, and how much storage is available on the edge device. In our case, our edge devices support anywhere between 1 and 50 machines each, depending on your configuration. And these edge devices, they're flexible. You can connect them over Ethernet, over Wi-Fi, or even cellular. So depending on that, there's a lot of different variables there, but what we see is we capture days or even weeks of data at a time in that buffer before it starts to run out.
Super interesting. Okay, I've got another one that came through. Are there multiple types of edge devices, or are they primarily those PCs that you showed us?
They come in all forms. So, I mean, if you really want to get technical, your phone is sort of an edge device. And it's so much so an edge device that I've got this sensor on my wrist, right? That as it's capturing information about my heart rate, it can send me a text and have me take action if my heart rate is too high. So we're already living and breathing with these edge devices, but now as they're starting to become more and more important in manufacturing, we're seeing all these other use cases about how we can treat the health of our machines like we're treating our own health.
Super interesting. Okay, another cool one came through. How much of predictive algorithms on machine metrics is related to machine maintenance against process performance?
Interesting. So when you think of predictive, at least in the sensor space, you need consistency in order to get enough data points to be able to recognize a pattern. And it's really common in things like wind turbines or aircraft engines where you have that very consistent process. With CNC equipment in particular, there's so much change that the problem is actually very challenging. To answer the question directly, most of our stuff is more based on maintenance and tool breakage. But when you start to talk about process improvements, there's even more moving parts. With machines, their tools are changing all the time throughout one cycle, and then different parts are set up and changed. So the machine's configuration changes, its entire behavior changes from making one thing to making another. So the predictive capabilities are really challenging. And then you get into actual process changes and it can be harder still. But as we start to learn more and more, we're recognizing a number of possibilities in each of these areas.
Cool. Okay, so here's another one. Can an edge device be specific to a machine, or can one handle multiple machines at the same time?
Yes. Yeah, we have customers that set these up in a number of different ways. For example, a customer might have a number of machines that are on a local area network, and we'll use one edge device for that. But then they have one machine that happens to be cast off in the far end where their Ethernet hasn't arrived yet, and they can use a secondary edge device just for that one machine, connect it to their shop network over Wi-Fi or out to the internet via cellular, and be able to capture data from that machine just the same.
Oh, cool. Okay, so here's another one. How many sensors do edge devices in manufacturing typically use? And are there limits, a recommended amount, too many, too little?
Yeah, it really depends on your application. I believe the edge devices that we ship, for the sensor piece, there's a second device that we happen to use, and everyone's going to be different here. But the device we use has about 8 sensor ports available, but there's extension cards, so you can add many more to that. One nice thing about a system like Machine Metrics is that you aren't limited to just one data source. You can actually have many data sources. The machine control can be one. It provides a large amount of information that's very accurate because it's coming directly from the control, and depending on the control type, that data varies. But then you can also add sensors to it as well. And we haven't run into a case where we wanted to add more sensors than we're capable of, but I'm sure there are use cases out there.
Cool. Makes sense. Okay. How fast can an edge react with multiple machines connected?
Depends on what you're doing. I don't know if there's chance for that person to clarify, but
Yeah, if
we're
you
talking in the
clarify.
millisecond range. It depends on what else that device is doing.
Right.
And you can also bring your own device. I mean, there are certain specifications we have to live by, but if you need more horsepower, that's fine too. And because the configuration of the device is stored in the cloud, it's not hard for you to swap out and replace that device.
Cool. Okay, we got another one. Thank you all for giving us these amazing questions. Okay, here's a good one. If a company implements an edge device, what skill set do they need to maintain its operations, just so it's working properly?
So for an edge device in general, in the general case, there are a number of different solutions out there that you could use to maintain them. But you're going to need probably some software engineering skills to be able to keep the software and the code up to date on them. In our case, we take care of that for you because we have all of the edge device management and fleet management services built into our product. You can see the health of your edge device in real time by looking at our edge management page. We keep your devices up to date for you. So there's really no technical requirements as far as that goes. It's really just making sure that the device is online, which we provide tools for allowing you to configure and manage that. But outside of that, there's really nothing else.
Cool. That's amazing. Okay. Ooh, we got two more. And then I'm sure more will come in. Thank you again, everyone. Okay, so when it comes to predictive analytics, is machine metrics really more of a tool life management than an actual machine element, like spindle, bearing, etc. life?
So one thing about machine metrics is that we are a platform that allows for us to build first-party applications, but also a platform for you to build applications that extend our capabilities beyond what we can even imagine. So starting out with some of the things we're doing right now, we're right now focused on things like tool life and trying to understand when a tool will fail. Not so much on process, but that's something that you could build yourself. You can learn from the data that's coming off of your machines, understanding your use cases, and develop algorithms that can be put on edge devices and take action in real time. I don't know if that answered that question. If it didn't, please ask.
Let us know. Okay. Can the edge devices handle older data formats such as RS-232?
Yes. So right now, I think one device that we connect to specifically over RS-232 is Haas machines. They speak a very specific protocol over RS-232. You can take another approach, though. We support a number of widely supported formats, protocols like Ethernet IP, Modbus TCP, OPC UA. So you can add a second layer in between, translate some piece of equipment that we're not familiar with into one of these more open protocols, more modern, slightly more modern protocols. Modbus TCP is actually pretty old, and translate that so that we can consume it. Another approach to that would be to use sensors. Certain old pieces of equipment, it sometimes just isn't cost effective to get the right information directly from the control, and it's much easier to wrap a current transducer, for example, which measures the current as it's passing through the cable that's powering the spindle. And we can detect with our sensors at 500 hertz when there's a sufficient amount of activity on that cable to say that the machine's running or not. We also use a couple other techniques with some other components within the machine that you can sort of speak Morse code to us and tell us that a part was made. So there's a few tricks and tips that we have for getting machines to provide really accurate data through sensors as an alternative approach to going directly to the control.
Cool. Okay, we got another one. Will you publish notifications of software updates or hardware updates being pushed down?
Usually we do that on a case-by-case basis. We have a process for keeping our devices up to date, but you can reach out to me if you're a customer and you have specific questions.
Cool. Okay. We don't have anything else coming in. I mean, is there anything you feel like you may have missed, Jacob, or anything you'd like to add?
No, I don't think so. I mean, this was really great. I appreciate all the questions. If there's anything else that anyone can think of, please feel free to ask. I'll hang out for a little bit longer. The possibilities really here are quite endless. By having compute right at the edge, it resolves almost all of the potential problems with the cloud, and the cloud allows the edge to take advantage of all of the possibilities of the cloud. So it's really a great relationship to have both of those tools at our disposal, and there's some really amazing things that you can do to improve your business with a cloud solution that offers edge technology.
Cool. Okay, we just got a product question coming in. What kind of support can Machine Metrics extend to help build machine predictive algorithms?
So we have a data science team that's dedicated to just that task. Our goal is to be able to provide the tools and the infrastructure so that you can be confident to build those algorithms yourself. But we're learning as we go, and we've done a lot of really tremendous things, but we know we can't solve all of the world's problem in this space, which is why we're providing the tools and not just building them ourselves. We're focused more on some more general use cases, but working with customers for their specific cases, really to learn and to help them take the reins and own that themselves as well.
Cool. Any success stories so far in predictive maintenance with Machine Metrics?
Yes, like I mentioned earlier, we have a number of customers that were quite a number of customers. I think I was told we've captured 2.4 trillion data points from high frequency data from our customers, and we're learning constantly from that information. As we capture that, we've worked with a number of customers to successfully detect with very high levels of confidence that tools will fail, and have developed processes for feed holding the machine, which is much safer than stopping the machine in the middle of its tracks. We can actually tell the machine, you probably shouldn't make another part, and then the machine actually decides to avoid making the next part, put itself in feed hold. So we've developed techniques that make that process safe, because that's another thing that we're definitely aware of and looking to address.
Cool.
Have addressed, yeah.
Okay. If machines are old and don't have standard communication protocols, how can I get my machine to the cloud?
Absolutely, yeah. So that's where sensors come in. Sensors are a really simple way. If we have the schematic of the machine, which is a good place to start, you got to understand there's probably a lot of relays that are available that actually describe what the machine is doing pretty accurately. And then we can use other sensors like current transducers or light pass-through sensors to detect when parts fall out of a part catcher, or that there's power going to the spindle or providing power to some component with the machine. And then we can further describe that as it's translated from the edge into our cloud. As the machine is running, a part was made. We can take those events and provide OEE and other really powerful data points for improving your operations.
Makes sense. Okay. Is Machine Metrics offering something comparable to platforms as a service, servicing the cloud? It's worded a little bit strangely. I don't know if you want to take a look at that one.
Is that in the Q&A?
Yeah.
Let's see here.
Something comparable to platform as a services.
No, I understand. So
Okay.
in effect, Machine Metrics is a platform as a service. We offer first-party applications that are very vertically focused on manufacturing, but we allow the product to be extended in new ways by building additional applications on top of our stack. You get that first jolt, a very significant jolt of productivity with the applications we provide out of the box. But there's going to be ones that we haven't imagined yet that you can use our APIs and our other systems and services to build on and create new things for your business.
Cool. Okay. Can Edge be used on continuous processes? Example, oil extractions from soybeans.
There's technically no reason why you couldn't. Our typical customer is more in the discrete space, but there's no reason why you couldn't use this in a continuous operation.
Cool. And we've got a question that I believe you already answered, but we can circle back to it anyways. Does Machine Metrics provide our own algorithms on the edge for predictive maintenance, or have any kind of specific support?
Yeah, you should reach out and you should discuss it. We do have some, but what we've found so far is that while some of them have broad reaching implications, there are a lot of tuning aspects to them, depending on the exact part that's being made and kind of the nature and shape of the data as the parts are being made.
Interesting. Okay, I mean, anybody else have some questions for us? Feel free to throw them in. Or you can always visit our website. We're easy to contact. Happy to forward anything to Jacob if needed.
Great.
Okay, I guess we'll wrap up. Thank you everyone for joining us for the Edge versus Cloud. Check out our website, machinemetrics.com/events for our upcoming webinars. Something we're focusing on a lot just through COVID to help support everyone. And yeah, thanks for joining.
Thank you all.
Bye, guys.